Today we are going to explain the solution for assignment 8, that is autoencoders and variational encoders. Autoencoders are nothing but these are the neural networks that we compress the data into lower dimensional representation, and after that we decompress the data into its original form. This is like these encoders are used in order to protect the data transportation from third party persons or like some people that steal our data. These are the necessary files that we download for using this. These are pip install dart. This is the code for this. Like this is the link for the code. After that, in the exercise one, we are first denoising the auto encoders. Here we are going to create an encoder and decoder, which will be used for denoising the autoencoder. And then we'll denoise the images. That denoise is nothing but we'll remove the noise from the images that we take or the data set that we take. These are the imported like necessary packages for you for this particular code. Firstly, we are going to import denoising autoencoder train underscore DAE add noise from DAE, and we are going to import variational autoencoder train VAE from VAE. After that, we are going to import operating system random NP numpy. We are going to import PLT from matplotlib.pyplot as the PLT for plotting the graphs. We are going to import torch, and from torch we are going to import NN. NN is nothing but neural network. After that, we are going to import F torch NN functional as F, and we are going to import transforms from torch vision. We are going to import MNIST CIFR train from torch vision the data sets. We are going to import data loader from torch.util start data, and we are going to import seed everything from PyTorch Lightning. We are going to set seed everything for 42, that's a random number, and the workers that's going to be true. This random PyTorch, these are the important for this particular code. We are going to transform the plot image, like we are going to transform the given image to the new form. This is how we load this data, and we are going to like implement these particular packages that we use in the following code. After that, we are going to load the data set by using this code. Here we are going to train data for two values that are true and false. Firstly, you are going to take CIFIR train and it's called train. Going to execute it, and we are going to train the data set when it is true and download it when it is true, and we are going to transform it to tensor form. After we are going to use this we are going to use start data, and we are going to take the subset as 5,000. In here, we are going to train the data when it is false. We're going to store it in subset when the range is like 1,000. Now, here we are going to create two data loaders using this CIFAR 10 underscore 10 and test. These are the two data loaders that we created by using data loader class. In the data loader class, it should be named as train loader, and the size of each batch should be like 128. It should be shuffled when the value is like true. This is a relevant link. After that, again, we are going to implement the following code for testing loader and training loader. That means we are testing the data and training, as well as we are like training the data too. This is how like we download the data to the content, extracting the content. After by using the following code, we visualize the images from CIFAR 10 dataset. and we are going to like plot the data by using this particular code. This is the subplots of like 2 comma 5, and figure size is going to be like 12:6 ratio. In the output inches are going to be like 80. We're going to run the for loop in enemy void train loader. It's like going to load x comma y is equal to batch and image. We are going to store the image into an array called to image when x is 0, like one dimensional array. After that, we are going to like load the data. I mean, load the image in this format. And when a line reaches to like 4, then we are going to like break the, we are like going to break the this one. Next, like we are going to finish the encoder of the denoising at the encoder by using this particular one. Like we are going to use some activation function called uh, RELU activation function. This is the code for like class that we are going to create by using class that we are going to use for creating encoder. This is a class encoder in neural network model. In itself, we are going to use it is super. It is all like super dark in it. We're going to create the encode as self, and we are going to use it as sequential. We're going to convert it into 2D as shown. These are the like 6 steps that we follow. First, we are like going to convert 2D layer into 3 channels, 3 in channels and 16 out channels, and a canal size is going to be 3, padding size is 1. This is how we do that. After the, we are going to activate the RELE activation function, and the max pooling will be like 2D layer, and the canal size is like 2, and like stride size is 2. In the fourth step, we are going to use convolutional 2D layer, where they're going to like 16 in channels, 14 out channels, and canal size 3, and padding size is equal to 1. Then we are going to again activate the really function. Then we are going to like take the max pooling where the canal size is 2 and stride size is of 2. And we are going to forward the self integer like this into x, and we're going to store it in return dot return of self dot encode x. And we are going to finish the out decoder by using the same format. This is we are going to have 4 in channels and convolutional transpose and 16 up channels in this and stride of 2, and we are going to like take it into 6 in convolutional transpose 2D layer. First we are like it has 4 steps as shown here. Here 16 in channels, 3 up channels, and 2 strides. Here going this, and we are going to use 2 activation functions in this. These are called RELU and sigmoid. This is how we like load the this decoder to, and after that we are like going to denoise the encoder by using this particular and this is how like we are going to use the noise and auto encoder and decoder in this. And this is the epochs that we are like going to use here. Totally there are like 49 epochs. And here like we can see how the training loss is like going to reduce from each step, from like first step to uh last step. And in the final step, the epochs like it's going to be like this much, and when it is in the start it's like this, and we can like clearly see how it's like reducing. And after that we are using the code to visualize the denoised images. This is how we take it. We are going to like plot it in a ratio of release to 8, and dot ranges are going to be like 80, and this is how we enumerate the test loader. This is like how we use. We're going to add noise to the image, and we are going to noise the noise image are going to be like stored in the noise x. This is how like we are going to show it. It's going to like break when I double equals to 0. This is the how the images are going to look when we introduce noise into that. In this exercise, like we are going to learn about variational autoencoders, So in variation autoencoders and create a fake number with it. Firstly, we are going to load MNIST dataset using the hello input or the we used to load the MNIST dataset. After that, we define the data loader from like MNIST and store it in MNIST loader. We should take like training set is going to MNIST and the basis is 28 and we're going to like shuffle when its value is true. This is how we do that. Extracting the data from MNIST. After that, we are going to you visualize the data by using this particular code. We're going to like plot it in a form of like graph. The figure points are going to be like valley street valley and dot points are going to be like city. And we are going to like do the background color as gray and we're going to show the image. This is how we do that. In this next step, like we're going to use the linear layers for calculating means and deviation of the numbers like this. We are going to like create a two variables called self.mu, self.variable. These are going to like using 16 in channels and 2 out channels. We're going to like use the forward, filling the code where it's going to be passed. This is how the code is going to be like worked. Class encoder, and we're going to like use a super variable in it, and we're going to like provide it for linearly function. Like it's going to be like batch size is going to be 128 and we're going to use redu function. This is how we use that. After that we're going to like use forward thing which is like going to pass the x value for this and we're going to like shape it and we're going to use reparameterization by using this and we're going to like calculate epoxes by using that. We're going to use me for this that is called mu plus st dot epox. Decoder class is taken for by using this code. We are going to like train it by using this, and this is how we get the epoch train losses, and this is how like we are going to see it's going to be reduced from the first epoch to the last epoch. And after that, we are like going to visualize and generate the fake images by using this. This is how this is the graph. I mean, this is the code that's used where we use to generate the fake images and plot them. Field size is going to be like 66 and dot points are going to be like 80. And this is how we use that. And this is how we generate the image.